Year 5, I'm back with another maths video, and today we're carrying on comparing fractions with a little bit more work today. So, our learning question, can I compare fractions that are greater than 1 whole? So our fractions might go into our improper fractions and mixed numbers that we looked at last week. But I've got some starter questions for you to have a go at on the board. All things that we've done so far. So pause the video and have a go yourselves, and then come back and we'll go through the answers. Okay, should have had a chance to go through those. So first we've got 2/9 is equivalent to how many 27ths? That's what this question's asking us. The equal sign in the middle tells us that these fractions are equivalent or mean the same. So what do we have to do to work out equivalent fractions? We need to convert them, don't we? So we need to look at the relationship between the numbers we've got. So 9 and 27, I know I need to do 9 times 3 to get 27. Whatever we do to the bottom, we need to do to the top number. So 2 times 3 is going to give me 6 27ths. And that statement is now finished. 2/9 is equivalent to 6 27ths. And moving on, we've got 7/9 and 14 18ths, and it wants you to compare these fractions and work out which one is bigger. And we know from yesterday's video that we can't compare different denominators. It's like trying to compare apples and oranges. We need to have this, they need to have the same denominator for us to compare them. So I'm going to convert my 7/9 into 18ths, and I'll just drive here. So 7/9 I want to put into 18ths. So 9 times 2 I know is 18, so I'm multiplying the 9 by 2. Whatever I do to the bottom I need to do to the top. So I'm doing 7 times 2, which will give me 14 18ths. So what symbol do we need to put to compare these fractions? Because 7/9 is the same as 14 18ths. So these fractions are actually equal. So we can just put the equal sign in there. They mean the same. They are the same value. And down here, it wants to know how many 7ths is greater than 1 whole. And this symbol here is telling us that this side needs to be bigger, needs to be greater. So first of all, how many 7ths are in 1 whole? We should also all know that it's going to be 7 7ths is 1 whole. So you could have any number in this box that is bigger than 7. So you could have 8 7ths, or you could have 9 7ths, 10 7ths, 11 7ths. The list is endless. As long as the number in here was bigger than 7, you can get that one right. And our last warm-up question, another comparing one. And we can see that we've got 2 19ths and 1/8. Can you all see that? Right, this one is a little bit different because you should have spotted there isn't a relationship between these numbers. So what I'm going to do, I could convert my 1/8, I'm going to multiply both of them by 2. And that's going to give me 1 times 2, which is 2. And then I'm going to do 8 times 2, which is going to be 16. And can you see that we've managed to get them to have the same numerator, both of these fractions? And this is something we're going to look at today. When the numerators are the same, when you're looking at the denominators, with fractions, the bigger the number, the smaller the fraction it is. Because if you split something into 19 pieces, each little part is going to be smaller than if we split it into 16. So when the numerator is the same, you need to think the bigger number is the smaller fraction, so that just tells us that 1/8 is bigger than 2 19ths. But that was a trick one in there, just to see who was switched on. We're going to look and go into that in a bit more detail now. So on the board I've got the two fractions, 11 7ths and 9 7ths. And I've drawn it pictorially for you to help to show both fractions, because like our learning question said, we are looking at fractions that are greater than 1, and we can see that I've got 2 improper fractions in my question here. Both of the numerators are bigger than the 7th denominator, okay? So I've got 11 7ths pictured here, and I've got 9 7ths on the second row, and we can see straight away which one is bigger. And we've got which the 11 sevenths has 2 more sevenths. There's 2 more sevenths than 9 sevenths. So we know straight away that that is bigger. When the denominators are the same, all you need to do is look at the numerators. We learnt that yesterday. But what if you've got different denominators and they are bigger than one whole? So I've got 7/5 here, which is an improper fraction, and 13/10, which is also an improper fraction. Now I've shown it pictorially because what we need to remember is the whole stays the same. We've just split it or cut it into different amount of parts. So on the top, our wholes have been cut into 1, 2, 3, 4, 5. And as you can see, I've got 1 whole and 2/5, or our 2/5. Let's write that information. We've got 1 whole and 2/5. Look at our bottom row. The whole has been split into 10 this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And of that, we've got 1 whole and 3/10. Just to keep our brains in gear with our converting that we did last week as well. But the picture also helps us to see that 7/5 is greater than 13/10 because we would need to have an extra tenth on the bottom row for them to be equal. So clearly 7/5 is the bigger fraction, and we would represent that like so. Are you with me so far? Right, another one, different denominators. Pause the video, have a go at this yourself, use the picture to help you. Which of these fractions is bigger? Now, this is another tricky one where the relationship isn't quite clear when we're looking at the two fractions. We can't make them have the same denominator. So this is where you have to remember, when the numerators are the same, you need to look at the denominators. And you can see that when we split something into 13ths, each piece is smaller. So the bigger the denominator, the smaller the fraction, or the smaller the part that you're going to get. You can see that in tenths, each individual part is bigger than our 13ths. Can you all see that? So that tells us numerators are the same. We're looking at our denominators. So the bigger fraction here is the tenths. It's the smaller denominator, but it is the bigger fraction. You get a bigger piece, a bigger part. So 15/10 is greater than 13/13. Can't speak. Okay. Word problem for you now, just to finish off this video. Pause the video if you'd like to read it yourself and have a go, and then join back in to see how I solved it. So, Miss Smart and Mrs. JB baked some cakes. They got a bit peckish and ate some of their cakes. And Miss Smart said, I have 2 3/4 left. And Mrs. JB said, I have 2 6/7 left. And the question is, who has the most cake left over? So who has the bigger portion after they've eaten some of their cakes? So what we're comparing are 2 mixed numbers here. And you can also see they've split their cakes into different portions. I've cut mine into 4 or quarters, and Miss JB has cut it into 7ths. So we've got lots of information to digest with this question. But what you need to do first is to see what is the same about the 2 mixed numbers. And we can see that they both have 2 wholes left. So we can discount those. We can ignore those, if you like, because they both have the same number of wholes left over. Then we are looking at the fractions that are left over, and that is 3/4 and 6/7. Now again, there isn't an obvious relationship between these two fractions to make them have the same denominator. And currently we are comparing apples with oranges. We've got 2 different denominators. So we need to think, can we make the numerators the same, like we have done in our previous questions? And the answer is yes. I can see that I could make 3/4 and I could make my numerator a 6 for this one. So 3 times what is 6? And that's nice and easy, it's 2. We need to do the same to the bottom. We need to do the same to the bottom and times 4 times 2, which will give us 8. We're now comparing 6/7 with 6/8. Now, who can remember what fact do we have to remember now when we were comparing numbers with the same numerator? We need to think that the smaller the denominator, the bigger the fraction, the bigger portion of the cake. So 6/7 is bigger than 6/8, because if you've cut something into 7, you would get more for your share. So, going back to our question, the answer is Mrs. JB has the most cake left with her 2 wholes and 6/7. I hope that makes sense. Watch this video a couple of times, have a go at the questions again, and just remember the rule of when the denominators are the same, you can just look at the numerators to compare, and when you can't find that relationship, if you make the numerators the same, you just got to remember that the smaller the number, the bigger the fraction. Best of luck. See you tomorrow.